Welcome to the Deep Dive. Today we're exploring a really groundbreaking topic, self-learning AI. Just picture a computer program that doesn't just, follow instructions.
Right.
It actually learns from its environment, it makes mistakes, and it genuinely gets better all by itself. To really get a handle on this, think about a kid learning to ride a bike. They wobble, right? They fall off, try again, maybe adjust how they're balancing, and slowly they get it.
Right.
Self-learning AI is kind of working on that same principle. But instead of a bike, it's learning from massive amounts of data.
It's a huge concept, really. And our mission today in this deep dive is basically to give you a full but, totally digestible overview. We want to unpack what self-learning AI actually is, look at how we even got here, talk about the big challenges it's facing right now, explore how it kind of mirrors how we learn as humans, which is fascinating, and then maybe peek into the next 10 years, see what's coming.
And just to set the scene properly,
Yeah.
let's quickly contrast it with traditional AI. If you're familiar with the old expert systems, the rule-based stuff, it's like a recipe, right?
Yeah.
Every single step is laid out.
Exactly. Very rigid.
But a self-learning system, it doesn't just follow the recipe, it watches, it tries things out, it basically writes new recipes for itself as it learns. That's the huge difference.
That's perfectly put. So, at its core, self-learning AI just means a computer program that gets better on its own. It does this by spotting patterns in data, trying different things, correcting its own mistakes, and crucially, without a human having to step in and rewrite the code every time it learns something new. And this isn't just like a technical detail, it's a fundamental shift in how machines interact with the world, how they pull knowledge out of it. We're talking about moving from intelligence that's purely programmed to intelligence that's, largely building itself.
That is a powerful difference. And it didn't happen overnight, did it?
Oh, definitely not.
To really get how we got here, we need to look back at these key shifts, each one sort of built on the last. Let's do a quick run-through of the AI eras. Okay, starting way back, like 1950s to the 80s, we had rule-based systems.
The if-then era.
Right. If this, then that. They showed machines could follow logic, sure. But the real takeaway wasn't just that they could do it, it was how quickly they failed with messy, real-world stuff. Things too complex to write rules for. They were just too brittle. And that really pushed research in a new direction.
Yeah, that brittleness was the key. It showed you couldn't just hand-code intelligence for the real world. It needed something more.
Which brings us to the 90s and early 2000s, the time of classic machine learning. So algorithms like decision trees, support vector machines, they started learning from data sets we gave them. This was the first real step towards computers learning from examples instead of needing explicit rules for everything. They started spotting patterns themselves. Then, maybe 2006 to 2012, we hit the deep learning boom.
Yes, the neural nets.
Exactly. Multi-layer neural networks, deep nets. They turned out to be amazing at things like recognizing pictures, understanding speech, processing language.
Yeah.
The big deal here was these brain-like structures gave us a framework you could constantly update. Models could keep getting deeper understanding.
And that ability to continuously refine, that really set the stage for what came next. It allowed models to go beyond just learning from a fixed data set.
Absolutely. Which led us into 2014 to 2020 with reinforcement learning and meta-learning.
AlphaGo territory.
Right. Reinforcement learning was about systems learning by basically trial and error. AlphaGo mastering Go, making moves humans hadn't even thought of. And meta-learning was even wilder, AI learning how to learn faster.
Learning to learn.
Yeah. It gave AI the power to sort of set its own goals, get much more efficient at picking up new skills. And now, 2021 to today, we're deep in the era of foundation models and self-supervision.
The giants like GPT-4, DLE.
Those huge models trained on, basically the internet. And self-supervision is this really clever technique where the model learns from unlabeled data. It kind of makes its own homework problems and then solves them.
It's a way to leverage enormous amounts of data without needing humans to label it all.
Which is huge, because one model can learn a ton of different skills and keep improving with just a bit of new data. Less need for expensive labeling.
Exactly. Each of these phases wasn't just an improvement, it fundamentally changed how we thought about machine intelligence. We went from simple rules to learning from examples to these complex structures that refine themselves, and now to systems that learn how to learn and even teach themselves from raw data. It's this whole journey that brings us to the sophisticated self-learning AI we see emerging today.
It's really easy to get excited about all the potential, but Like any big technology shift, there are some serious challenges.
Definitely.
In fact, some of these hurdles are maybe just as complex as the AI breakthroughs themselves. What are the really big ones we need to keep in mind?
That's such a critical question. And these aren't just abstract technical problems. They have real impacts on all of us. Let's break them down. Okay, first up, data hunger. Most of these self-learning systems, they need millions, sometimes billions of examples to get really good.
Wow, billions.
Yeah, and that means collecting, storing, cleaning massive data sets. It's incredibly expensive, uses a ton of resources, and of course, raises big questions about data privacy. Then there's safety and unpredictability. When a system is basically writing its own rules as it learns, sometimes it comes up with strategies or behaviors you just didn't expect.
Like finding weird loopholes.
Exactly. Or just acting strangely in a situation it hasn't seen before. Think about a self-driving car doing something unpredictable. That can be genuinely dangerous, especially in high-stakes areas like medicine, transport, finance, and a really significant one, bias and fairness. The data we train these systems on often reflects our own societal biases, right?
Unfortunately, yes.
Well, the AI learns those biases too, and it repeats them. This can lead to really unfair outcomes in hiring, loan applications, even court decisions. It erodes trust and just makes existing inequalities worse. Another tough one is interpretability, or the lack of it. People talk about AI as a black box.
Right. You can't easily see why it made a certain decision.
Precisely. Inside a deep neural network, it's just this incredibly complex web of numbers, making it really hard for us humans to explain the reasoning. And that makes accountability very tricky, especially when things go wrong. We also have to talk about energy and compute needs. Training one of these huge state-of-the-art models, it can use a staggering amount of electricity.
Like how much?
Think maybe as much as a small town uses in a day, just for one training run.
Whoa.
Yeah. So there are serious sustainability issues. Plus, it means only really big companies or well-funded labs can afford to build these cutting-edge models. It concentrates power. And finally, there's regulation and governance. The tech is moving so fast, laws and ethical guidelines are struggling to keep up.
The classic problem.
It creates uncertainty for developers, for businesses, and it leaves the public feeling, understandably, a bit uneasy about where things are heading without clear rules of the road.
That really does lay out the challenges clearly. It makes you think, doesn't it? If AI learns our biases, how do we build ethical guardrails that actually keep pace? Is it tech? Is it laws? Or something deeper in society?
It's likely a mix of all three.
Understanding these challenges definitely isn't just academic. It's vital if we want to integrate AI responsibly and make sure it actually benefits everyone. Okay, let's shift gears a bit. Let's talk about something that makes this tech feel a little less alien. How self-learning AI actually mirrors some aspects of how we learn as humans.
This is a fascinating area.
These parallels, they're not just cool trivia. They show where AI gets inspiration, but also maybe where the limits are.
That's a great way to look at it. Because while the mechanics underneath are totally different, silicon versus biology, some of the high-level learning strategies look surprisingly similar. Okay, think about curiosity or exploration. For humans, it's that drive to poke around, try stuff out, see what happens.
Right. Kids do it all the time.
Well, in AI, especially reinforcement learning, you have exploration. The AI deliberately tries new, sometimes random, actions just to see if they lead to a better outcome, a bigger reward, like a game-playing AI trying a totally weird move to see if it unlocks a hidden advantage. Then there's practice and repetition. Obvious for us, right? You practice piano, you get better.
Sure.
For AI, it's retraining on new batches of data. Your voice assistant gets better at understanding your accent the more you use it. It's essentially practicing with every interaction. We all learn from mistakes, hopefully. We mess up, we adjust.
Try not to make the same mistake twice.
AI has mechanisms like gradient descent. After it makes a wrong prediction, it tweaks its internal settings, its parameters, in the direction that reduces that error the most. So a self-driving car model might adjust its steering calculations after it predicts a lane incorrectly. It learns directly from that specific failure. There's also a kind of transfer of knowledge. We learn one thing, say, riding a bike, and maybe some of that balance skill helps when we try skateboarding.
Okay, yeah.
In AI, meta-learning touches on this. Learning how to learn helps AI pick up related tasks faster. A big language model might learn a new dialect or even a coding language with very few examples because it's grasped the underlying principles of structure. And finally, there's even a form of social learning. Humans learn by watching others, seeing what works for them. In AI, you see this in multi-agent systems. Imagine robots in a warehouse sharing data about which routes are fastest or avoiding collisions. They learn from each other's experiences to make the whole system work better.
It really is amazing to see those echoes. But, like you hinted before, there's still a huge gap, isn't there?
Oh, absolutely. A profound one.
These parallels are cool, but AI doesn't have consciousness, real emotions, that deep, abstract, long-term thinking we do. Or the ability to set its own, truly personal goals. It's still a tool.
Very sophisticated tool, but a tool nonetheless. And understanding that gap, what it means for AI's future and its relationship with us, that's still one of the biggest questions out there, both scientifically and philosophically.
So putting this all together,
Yeah.
what does it actually mean for you, for us, in the next few years? Let's try and peek into the future a bit. What might the next decade of self-learning AI realistically look like?
Okay, looking ahead, we can kind of map out some likely steps, some breakthroughs, and what they might actually mean in the real world. So in the next 1-3 years, I think we'll see big strides in data-efficient learning.
Using less data to learn.
Exactly. Things like few-shot learning, where AI learns a new thing from just a few examples, and better self-supervision, needing even less human labeling. We'll also see better safety toolkits emerge, ways to spot risky AI behaviors before they get deployed.
And the impact for us.
Think smarter personal assistants. Ones that really adapt to your way of working or talking after just a little bit of interaction. Much more personalized. Okay, moving out 3-6 years. I'd anticipate seeing self-repairing models. AI that can actually detect its own errors and fix them automatically.
Wow, okay.
And on the hardware side, more energy-lean architectures. Things like sparsity, making neural nets run more efficiently, or neuromorphic chips that mimic the brain's low power.
And the impact.
More reliable autonomous systems delivery drones that fail less often, maybe industrial robots too. And for companies using cloud AI, lower electricity bills. More sustainable AI. Now, looking out 6-10 years, this is where it could get really interesting. We might see true generalist agents, AI that can handle a whole range of different tasks, scheduling your meetings, drafting emails, troubleshooting your computer without needing to be retrained specifically for each one. At the same time, we should see much more mature governance frameworks, proper industry standards, ways to certify AI safety, clear audit trails.
Okay, so more capable AI, but also more regulated.
Hopefully, yes. The impact could be everyday AI partners, helping with work, learning, health, but with systems in place so we can trust they're reasonably safe and fair. And then, if we really speculate, beyond 10 years, who knows? Maybe AI that can propose its own useful goals, self-directed goal formation, or even true human-AI co-learning, where we're iteratively teaching each other.
That sounds like science fiction.
It's definitely speculative, but the potential impact is, well, transformative. AI augmenting creativity, speeding up science, helping solve really big global problems collaboratively. But the main trend, the takeaway for the next decade, self-learning AI will get much more capable, yes, but also, hopefully, more responsible. It's moving out of the labs and into our lives, homes, schools, workplaces, and ideally, that progress will be shaped by better safety tools, clearer standards, and importantly, ongoing public discussion.
That's a fascinating roadmap. Okay, let's quickly hit some common questions people might have right now. First one, do I need to be a programmer to actually use this stuff?
No, absolutely not. For most people, the complex AI will be hidden behind really simple interfaces. It'll be more like just asking for what you want. Think natural language.
Okay, next big one. Will self-learning AI take away jobs?
It's definitely going to automate routine tasks, no question. But the hope and the goal for many is that it frees people up for the higher level stuff, work needing creativity, empathy, complex judgment, things humans are still uniquely good at. It's more about augmentation than pure replacement, ideally.
That makes sense. How about data privacy? With all this learning, is my data safe?
Well, there's a big push towards more privacy-preserving techniques, things like federated learning, where the AI learns from data on your device without the raw data ever leaving it. But you still need to be careful. Always a good idea to read those privacy policies.
And the really big question, can AI become conscious?
Right now, no. Today's self-learning systems are incredibly powerful pattern-matching machines. They're not conscious like we are. Consciousness itself is still this huge mystery, philosophically and scientifically, way beyond current AI capability.
What an incredible journey we've taken in this deep dive. We've covered so much. I think the main thing to hold on to is this idea of self-learning AI as like giving computers a learning toolbox one that keeps getting bigger and better. It lets them improve on their own, kind of like that child learning to ride a bike, learning from experience, from feedback. And that toolbox is just expanding incredibly fast.
Absolutely. And understanding that whole story from those simple old rules right up to the potential for these intelligent partners, it really helps us appreciate the speed of progress, but also the crucial next steps we need to think about, as a society. It's about being engaged with it, not just watching it happen.
For sure, because that learning toolbox, it still needs really careful handling so we don't have, accidents along the way, especially as it gets more autonomous. Looking 10 years out, we can probably expect AI that's smarter, safer, woven much more smoothly into our lives if we keep asking the hard questions now and pick the right kinds of safeguards. So the question for you is, what questions will you be asking about the future of these learning machines?
Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.